So, going to do a quick little video here. I normally don't do this. I do it all, I think, as we go along. But I want to do a video on the units of all this stuff that we've been talking about for electromagnetism here more recently. In particular, I want to do this because there's something that there's like kind of something we have to do with a special new unit that's not an SI unit, but it's a very useful unit and one you're going to have to get kind of used to. And I wanted to take a special time just to go over the units of this stuff. So we had voltage we defined was our potential energy per charge. So if we look at that, it ultimately gives us a unit of, well, a unit for potential energy is a joule, and the unit for charge is a coulomb. So it's a joule per coulomb, and we're going to call that a volt. It's a capital V. So voltage has a unit of a volt, and they're both capital V's, and so don't let that confuse you. You have to pay attention to the context. If you're looking at something like this here, it's an equation where it's being used as a variable, then obviously it stands for the variable voltage, the actual thing itself. If you see it written after a number, like if you have like 5V or 7.2V or something like that, it's most likely then a unit if it's written after a number where it's a unit. So I could have something like, I could have Q time, I'm sorry, not that. I could have potential energy divided by charge or something equals 5 volts or something. Maybe that's not the best example, but whatever, you know what I mean. If it's written after that number, it's most likely a unit. Maybe ignore that example. The next one, this is the one that really takes a few seconds here and why I wanted to make this special video. It's a different type of unit for energy. It's a new unit for energy because when you start working with these small little point charges and these particles and electrons and stuff like that, a joule becomes a huge amount of energy, and we don't start to work with that. So what you do is you make up a new unit called the electron volt. Okay? If you think about it, a volt is a volt is a energy per charge, and so what we can literally do is write the charge of an electron times 1 volt, and that's 1 electron volt. It's an EV. And so if you see this unit, it's very easy to convert this to joules because it literally means elementary charge times 1 volt. So you can just substitute this out as 1.6 times 10 to the negative 19th coulombs times 1 volt, which is 1 joule per coulomb, and you'll see the coulombs will cancel, and you'll be left with 1 electron volt equals 1.6 times 10 to the negative 19th joules. The coulombs and the coulombs cancel. So it's a very small number. It's very small compared to a joule, and so it becomes very useful when you're working with things, when you're working with these particle physics. And you'll see more and more as we do this how it comes about, and it actually just kind of shows up naturally, and it's very easy to just go ahead and just leave the charge as E and not worry about doing it. It saves you some time and saves you some math and saves you having to deal with really small numbers and powers of 10 to the negative 19th and stuff like that. Okay, the last unit is dealing with current, and it is simply that current is our rate of flow of charge, so it's charge per unit time, and that gives us a unit of a coulomb per second, and we're going to define that as an amp with a capital A. 1 amp is 1 coulomb per second, and that is the unit for our current. Okay, so that was pretty much it. Just a quick short little video to kind of give special attention to this electron volt, and then while I was at it, I thought I should just go ahead and I thought I'd just group this into one video over all the units rather than a bunch of smaller ones. So anyway, that's just about it.